day to Madam and friends. Today, we are going to present our mini project which our topic is about ideal gas law. We have created a learning platform about this topic by using MATLAB GUI. Before I start, I'm going to introduce myself and my team members. My name is Kathy Ling with metric number TJ20015. Next, Fatini Nasuha with metric number TJ20019. And the last one is No Irene Shahira with metric number TJ20018. User can learn the basic knowledge about ideal gas law, which are Boyle's law, Charles' law, Avogadro's law, and also Gay-Lussac's law. User can also find compressibility factor for air and type of gases for that air. By this, user does not need to refer to the compressibility chart every time they want to determine Z factor. Our project will make students easier and a faster way to learn about ideal gas law. Gas law is the combination of four simple gas laws, which are Boyle's law, Charles' law, Avogadro's law, and also Gay-Lussac's law. Boyle's law states that the volume occupied by a fixed mass of gas is inversely proportional to the pressure. Charles' law states that the pressure is directly proportional to its temperature. For Avogadro's law, it states that the volume of gas is directly proportional to the number of molecules. Gay-Lussac's law states that at low pressure, the volume of gas is directly proportional to its temperature. This combination of gases gives us an ideal gas equation, which is PV equal to RT. There is also another mathematical way to describe ideal gas law, which is PV over RT equal to 1. The term PV over RT is called compressibility factor Z. If the value of Z is equal to 1, then the gas is an ideal gas. If not, the gas will be a real gas. Ideal gas law can be useful in our daily life. For example, we can use ideal gas equation to find the pressure of our car tires during a vacation.
Hi, my name is Fatina Suar, TJ20019. So the problem statement that we found are the student lacks of interest in learning ideal gas law and having difficulty to distinguish the types of gas law. Other than that, it is also difficult to calculate the value of Z to distinguish the ideal gases and also the real gases manually, as we have to refer to the table. Hence, the results are not accurate. It is also complex and time-consuming to observe the value on the graph. It is important as the observation on the graph have higher risk to produce inaccurate results. And if it is inaccurate, we need to check the whole calculation again. This phenomenon is actually observed firsthand by the students in thermodynamic classes, where they confuse about types of gas law and they need to observe carefully and using the ruler to find the exactly value of Z on the graph in a short time. This problem affects the performance of the students in learning gas law. For the objective, as you can see in my slide here, the objective of our project is to create an interesting way that can attract students in learning types of gas law using GUI method. The students can also having fun during their learning time and test their knowledge with the quiz about ideal gas law that have been provided in this GUI. This is important as ideal gas law actually in thermodynamics is a very crucial topic for engineering students. We also aim to develop an easy way to calculate the value of compressibility factor, which is Z, of air accurately in a short time. For main GUI, we have GUI home, GUI types of gas law, GUI compressibility factor Z, and GUI quiz.
Assalamualaikum, my name is Nur Irene Shahira binti Johari, TJ20018. I will explain more details about our MATLAB coding. As you can see on the screen right now, our MATLAB coding consists of selection function where we use if-else-if in compressibility factor to determine the type of gas, where if Z value is equal to 1, then it will appear a message box say that it is an ideal gas, otherwise it will appear it is a real gas. For repetition function, we use for loop to create a graph for all types of gas law. Next, user input where the user could enter the value of P, pressure, V, volume, and T, temperature to calculate compressibility factor Z, as well as has a choice to select which one they wanted to learn. Apart from that, mathematical solving such as PV over RT equals to Z also used to calculate Z factor as well as other mathematical equations to plot a graph. Lastly, it also contains formatted output, or we could say that user could enter multiple input and got multiple output from our project. For output of our program, let's play some video to have a better understanding of how our project works and what the output we provided.
As a conclusion, our mini project is the combination of many good. Our proposal is to create an interesting way to learn types of gas laws such as Boyle's law, Charles' law, Avogadro's law, and also the Gay-Lussac's law. The user can also test their basic knowledge in this topic in the quiz GUI. Other than that, as you can see in this here my slide, user can also calculate the value of Z in easier and also faster way with an accurate result. User can also find out the types of the air, whether it is a real gas or an ideal gas with the value of Z that was calculated.
There's some suggestions for further improvement of our GUI project. For example, our GUI should have gas constant for all substances in compressibility factors GUI. By this, user can calculate all type of gas instead of air only. Besides that, our project should have a reset button for compressibility factors GUI. The user can delete their previous input value that was inserted previously. Also, we should set the radio button into one selected item only. By this, user can only select one answer automatically.